So we are going to cover the first episode where we are going to talk a little bit about what is reproducible research, why it's important, and how it relates to the software that we write to support our research. So I've got a couple of slides, and then we will move on to start working with our project. So you might have heard about the reproducibility crisis and across different domains, across different subjects, and the need for being able to, well, repeat research. So reproducible research is a practice that ensures that researchers can repeat the same analysis multiple times with the same result. And it's got several benefits. So why would we care about reproducibility? Well, reproducibility helps ourselves because we can remember and know why we performed certain task and analysis. And it also explains us to explain our work and research to either our work collaborators or to reviewers of our work. And it also enables us to quickly modify, for example, some analyses or figures that we did if we can repeat our research and tweak some parameters and make sure that we can rerun our analysis with certain tweaked or different data or different input parameters. That's very important for a quick turnaround, and this is often required at different stages of research. For example, sometimes when you publish or want to publish your research, maybe reviewers will ask for you to do some tweaks to your research methodology. And if you have software that supports repeating that research relatively quickly, then you'll be able to quickly do what they've asked of you. So reproducible research also enables reusability of previously conducted tasks so that any other project that comes after your project that requires either the same or similar tasks, it becomes much easier for them and more efficient by reusing or just reconfiguring previous work. Finally, reproducible research will support your career development because it will facilitate reuse by others. You will be able to get some credit. You will be able to get some citation for all of your research output. So not just for the papers that you publish, but also for the data that you publish and make available to others and the software as well. And reproducible research is also a strong indicator of rigor and trustworthiness and transparency of your scientific process. And it can increase the speed of peer review because your reviewers will be able to access the analytical process that's described in your manuscript. And also being able to share your work with a large number of colleagues who will be able to look into it will make sure that any potential errors or mistakes are uncovered early on, and then you'll be able to fix them in the earlier stages rather than in the later stages where it becomes a bit more costly. So because software is crucial for most of modern research and its reproducibility, we also need to make sure that the software that we write is robust and correct. And this is the case across different and all domains and fields of research. So we will cover some of these well, we used to call them good research software practices, but we now try to say better research software practices. So anything that improves from our past practices, we consider an advancement. So we talked a little bit about the FAIR framework. So the reproducibility hinges on the openness and on the FAIR research software principles. So as I said, being able to have a look into someone's work and be able to repeat it or replicate it, potentially find some mistakes is really crucial. So that's why we we try to instill this openness mindset in everything that we do. Sometimes it's not possible to share your work. Sometimes you don't want to share it early on because of various reasons. Sometimes you have some privacy concerns. Sometimes people feel a bit self-conscious about sharing an unfinished product, or maybe the code that they don't think is good enough. But we are all in a similar situation, and I think the earlier that you do share it with others and get someone else to have a look into your work and your code and get a second eye and some comments is actually more beneficial, and we shouldn't be shying away from that. In terms of the FAIR software principles, they stand for findable, accessible, interoperable, and reusable. So we should be able to, well, first find other people's software and also enable our software to be and data findable by other people if we want to support any sort of reusability and reproducibility. Once we find and discover a piece of software that we want to use, we should then be able to access it. We should be able to download it using some standard protocols. But it's not just about being able to download the software. It's also accessibility is also about, well, do we actually have the right to reuse this software and to modify it for our own purposes? Interoperability of software means that it should be using some standard protocols when it's talking either to other software components or maybe to different software components within the same software project. It should be using standard data formats and data passing protocols rather than inventing some proprietary software. That will also help many people around the world understand it if it's using some standard protocols to interoperate between different software components. And finally, once you find and access the software, and you should actually be able to install and run it on your machine. So it should be working across different platforms, across different operating systems, rather than just on a single machine. So over the course of the workshop, we will be using and learning some practices that will contribute to the openness and the FAIR software principles, but also to some other principles that will help with overall reproducibility of our research that relies on software. So other aspects of these good or better software practices we will cover is code readability. So can others read and understand our code? And this also goes for ourselves 6 months down the line when we look into our code and can't understand what we meant to do and what we wrote. Code documentation. Can other people install and run our code? Do we provide documentation for them to do so? Can they modify our code? Is that clearly explained? Code correctness, again, are we confident in the results that our code produced? A little bit on code automation, how we can run the tests, checks for our code across different platforms and operating systems. And then finally, collaboration, really important aspect of research software. Can we actually work on this software as a team? Do we support collaboration, contributions, and reviews from other people in our team, and perhaps from other teams and other countries, and so on? So just looking at the FAIR software principles might not be enough. We need to your code might be perfectly fair, but it still might not be correct and might not be of good quality. So it's important to look into these other practices that can support reproducible software. And again, this is a non-exhaustive list. We can't cover all the good practices. We will cover some of them as I've listed here. But yes, we encourage you to look into other practices and carry on learning after this workshop. Okay, so when is a good start to think about engineering your software rather than just coding? So you can think of the code as writing in a natural language. So you know how to write in your first language, but there is always some good practices that you can learn to improve your writing style. And the same is true for coding. Yes, you can write code that is syntactically correct and that will run and won't throw any errors, but it doesn't necessarily mean that software is following some good coding styles, and that the software is necessarily good, like in a natural language. So the things that we will be doing is we will be covering a couple of things. We will be looking into the things that you can do with your own computing environment locally to improve the quality of your software. So things like using virtual development environments to ensure that your software is isolated from other projects on your system so that there are no clashes between their dependencies, and also make it easier for you to share this software environment so that other people can replicate it on their machines, whatever operating system they are using or whatever platform they are on. Secondly, we will be looking into things that we can do to improve the source code of the software itself. So things like organizing our code and structuring our code, as well as our software directory, software project directory, that will keep our project clean and modular and reusable, and helping to enhance its readability and extensibility and reusability. So things like following coding conventions for your programming language of choice that will ensure that your code is consistently written and that others can more easily read and understand it. Writing structured documentation and comments in your code, again, to make sure that it's more understandable for people who want to use or extend your code. Testing can save time spent on debugging and ensures that the code is correct and that it does what is set out to do, giving yourself and others confidence in your code and the result it produces. And finally, the third thing that we will be covering is that things that you can make the software easier for other people to use. So making sure that you're using version control and collaboration platforms like GitHub or GitLab or Codeberg, making it easier to share your code and work together with other people on it. And also helping us foster a shared team ownership around your software. So you're not working on it on your own, but we are promoting collaboration, which will help to grow either your user base or your collaborator base or your maintainer base, for example, after your project finishes. And all of these things contribute to the long-term sustainability of your code and help us avoid a single bus factor. And all things like providing clear and comprehensive documentation, for example, writing API specifications for your code, setup guides, user instructions, all of these things help ensure that your code is more easier to understand and use and extend. I just want to highlight, we are not here to criticize anyone's code. We are here to learn from one another and from each other's mistakes and to learn a better way to do things. When I was doing my PhD, I didn't use any of these practices, maybe few. I didn't use version control at all. I I had zero tests. My code had zero tests. Um, at some point, a colleague joined and mentioned version control, and we started using CVS, which is an old version control system, used probably 20 and more years ago. I started using that system, but what I was doing is I was backing up my work, but again on my machine. So if my machine crashed, even though I had it backed up and I used some kind of version control, it wouldn't really help me. We didn't use any central server to back up and sync our code. That was my first experience with version control. Later on, I joined what is now called the Research Software Engineering Group. It wasn't the name that was used back when I joined it, and things were a bit better there because there were loads of colleagues who knew about these good practices. We switched to another version control system, SVN, and we have set up a central server where all members of the team were syncing. So things have gotten progressively better for me there. And my background is computer science. I did a computer science bachelor degree, and I was not taught any of these things as part of my undergraduate degree. So I've learned everything on the job, really. Luckily, things have moved on, and things have improved since then. But I suppose there is always a little something that can be learned and taught. So, okay, what we are going to do now is we are going to move on to the first teaching episode, as it were, where we are going to start working with the software project that we've inherited. And what we are going to do now is let me just have a look. So before we do that, the way how this workshop is going to work is we are going to pretend that we have inherited a software project from a colleague that has left the group. So the Spacewalks software that you might have downloaded is something that you inherited from a former member of the group. And this is a typical experience. Well, it used to be a typical experience. You just get someone's piece of code that you need to read and understand, and that you have to carry on working on. And often the software was shared with you via an email, so you would just get a zip archive. And this was happening very often in the past, and I think it actually still happens. Things might have moved on a little bit. Maybe you get code in a version control, maybe in a GitHub repository now. But I think when I was speaking to Alex as part of preparation for this course, Alex Little, I think he said he's got the exact same experience. Alex, do you mind if I just call out for you and maybe you say what happened to you?
Yeah, so well, quite recently as a RSE, we were given some code um, from a researcher whose postdoc, I think, had written it in their time as a postdoc and then had left for something else. And they needed us to make sense of it. And while it did have version control, there were some good sort of software practices. There was also quite a lot of things in there that were less good. And our job was to try and take this, essentially applying all the principles you'll be learning in this course, to take this code from where it was to something that then they can continue to work on and build on. Um, is that the example you were thinking of? Was that the Yeah. Um,
Yes,
I mean, I thought of maybe a specific. Some of that was writing tests. Some of it was looking at the sort of code readability and documentation, the code, things like that. So yeah, all of these topics will be covered in this course, I believe.
indeed. Okay, thanks very much for that. Has anyone got similar experiences that they want to share? How do people normally share their code
Yeah.
with? Yeah, go
I
ahead.
can also share an experience, similar experience. When I was working in Barcelona, I joined a group and we received also as email zip uh, like project, and we were the fourth group working on this same project, and every group had started from scratch trying to understand the previous code. No version control, no actually no documentation at all. It was just a bunch of files and codes. And when I would ask, like, why are we using this particular variable, then we found out that some variables weren't even used, but they were created like ages ago by a previous group, and then they stayed there in the code, and yeah, just lived there forever.
Thanks very much for sharing. I think these things with unused variables is one of the things we will cover because our uh, software that we've inherited contains some of these as well, which don't really help with readability. So I'm really glad that you brought that example up. And also I just want to say that sharing software and between people using, for example, a repository on GitHub or similar code sharing platform might not help with everything. It's probably a first step. So you can share the software with in GitHub, but and still it still might not be very readable and very reusable. But at least it's a first step, and you might be able to look into some of the past work because it will be documented as commits that you can go back in time and you can have a look at what happened to the code, provided that people put some meaningful commit messages when they were saving their work. So yes, it does still happen. And again, we are not here to criticize. We are here to learn some better ways of doing things. So before we start looking into the software project that we are going to inherit from someone who's left our team, I just want you to reflect for about maybe 5 minutes. And I've just pasted the text of the exercise in our shared document. It's just below line 93. So I just want you to think about what practices or tools you're already using in your software development workflow and list some of them. So list what you're already using and maybe list some of the practices that you would like to start employing or using. And if you would like to just share your thoughts in the shared document below the text of the exercise, you don't really need to, you can do it anonymously, you don't really need to add your names, but just maybe tell us what it is that you're using now, either practices or tools, and then people can also do a plus one if they also use the same tools. Let me share my screen again. It looks like loads of people are already using Git and GitHub, which is really good. To the person that said, I don't use anything at the moment, I know I should be using it, but don't feel confident. Hopefully, we'll get you to the stage where you will feel confident to start using it. Feel free to ask any questions, either in the chat or by speaking up. We are here to help. And I'm sure you're using some tools and practices. Since you're in this workshop, you are probably already using some things. If you're using a programming language, maybe you're already on the good to code your research analysis. You're already on the way to improving your practices. Okay, so I can see some people are already using test frameworks, PyTest. Other people are keen to learn more about tests and maybe scaling up and automating execution of the tests with continuous integration. We also have more experienced developers with us who are working on different open source projects. That's really, really good. It's a good start. Using a logger to keep track of important events in the code execution, useful for bug identification. That's really, really great start. We have another course which we call intermediate development with Python that covers a little bit more on debugging. So I'll ask one of my colleagues to paste a link to that course in the case people are interested to have a look. It covers similar topics to this course, but it goes a little bit more in depth into the software engineering practices. Okay, so that's really, really good. Is anyone willing to maybe tell us about their struggles or what they hope to learn from this course? Don't worry, I'm not putting anyone on a spot, but if anyone wants to share, I'm sure the struggles are shared. Or maybe we can ask uh, I think Gunnar, is that yourself who's got this project to move from Subversion version control to GitHub? Do you want to tell us a little bit about that?
Sure. Yeah, I mean, that's one little part of the project. So yeah, the Software Sustainability Institute, yeah, wonderfully chose this project that we put in last summer as one of the ones that they funded in the first round of the Research Software Maintenance Funds. And so our project will bring together actually two libraries. So one is Dark Hum, which currently lives in Subversion, and I mean, it's not originally conceived as a community shared library, but has really become adopted quite widely. But really, it's a collection of multiple programs that use a common code source, and we want to, yeah, improve the structure and also bring it together with another library, which is called Algorithms and Libraries for Physics Simulations, which is well, a very major international project involving people from multiple places. And actually, since Software Sustainability Institute, there's been further good news on this actually. So ALPS has won a National Science Foundation POSE2 award. So there was a big program in the US to work on code sustainability. And so ALPS was part of the first sort of initial scoping phase, and now they've won a fairly big award, which will help them hire a couple of software engineers. So we'll have a team there to interact with on that US side as well. So they should start up around a similar time as us. So it should be a really fun collaboration. And yeah, so by the way, one of the reasons I attended here was just to see who else is out in the space. And so if anybody's interested in maybe contributing to those projects, and yeah, do feel free to get in touch. I'd be very happy to chat to you about that.
Well, thanks very much and congratulations on all these fundings. It's really good to see these international collaborations happening. And thank you very much for sharing. I'm sorry for if I put you on a
No,
spot,
perfectly
but
fine. Thank you.
it just sounded like an interesting thing to learn about. I can see some people are also sharing a Conda environment file. So this is something we will be covering as well, sharing your virtual software environment with others. So that's already one good practice employed right there. I've also seen someone mention they're using or they would like to use a tool called UV soon to manage their software project environment. So we won't be covering UV. We will be using some different tools to manage our environments. But we also try not to teach specific tools. We try to teach people the practice of sharing and setting up and isolating research software environments, whichever tool you choose to use in the future. And UV does seem to be getting loads of traction recently. Okay, well, thanks very much for that. So what we are going to be doing now is I'll just ask you to give me a thumbs up if you've downloaded the software spacewalks.zip from the installation instructions. So give me a green tick if you've downloaded that code, and I'm going to go ahead and do that now. So someone has just sent me this zip archive and I'm going to save it on my desktop, but feel free to save that anywhere on your machine. So if you've not done that, give me a red cross. So I'm going to save this archive and I'm going to unzip that. So let me just see what the situation is like. Looks like need a few more green ticks, but looks like most of people have done. So for people who haven't put a green tick, one of my co-instructors will paste the link for you to download this code. So what this zip archive contains some NASA open data on spacewalks. So they call these extravehicular activities, or EVAs, which have been undertaken by different crews between 1965 and 2013, and contains some Python script that analyzes and plots this data. So I'm going to assume that people are ready to carry on. So I'll just clear the feedback, and then we can carry on. What we are going to do is we are going to use VS Code to open this project. So if you can fire up your VS Code for me, we are going to open the software project now. VS Code is an integrated development environment for software development. It's commonly used by researchers. We did a little survey to see which tool is most popular among researchers who code, and Visual Studio Code seemed to win. So we are going to be using this for the course. But if you're using another IDE, that's absolutely fine. We'll try and help you. If you want to follow along, it's probably the best to use Visual Studio Code for this workshop. But you may choose to use something else. Okay, so IDEs are very useful. Well, they're graphical applications, first of all, that provide comprehensive facilities for writing code and editing, testing, debugging, and they provide all of these facilities in one place. So normally they have an advanced code editor that does some syntax highlighting and help us develop code, and also helps us with streamlining the code development process. And they are very useful for code development, and modern software development would be extremely difficult without these tools. So VS Code is one of these IDEs, and it integrates loads of these features either natively, or you can install these extra functionalities through a large number of extensions. So what we are going to do now is we are going to open our software project. So I'm going to click here on the Open button, and then I'm going to select from my desktop, I'm going to select the folder that I got by unzipping the spacewalks.zip archive, and I'm going to open it. So I'm going to ask you to do the same. And you should have something similar to what I've got on my screen. So because I know that not all of you have used VS Code extensively, I'm just going to do a little intro and to orient ourselves around while everyone is opening their Spacewalks folder. So here on the left-hand side, we have we have a vertical tab with couple of options. The first option is the File Explorer or the File Navigator. So if you click that, you get the list of files in your project, so you can explore what files and subfolders exist in your current project. The next is your search button, so you can search for text in your files in the current project, or you can also do a replace for a piece of text. The one after this is the source control, which gives you access to the source control, so version control, which includes Git version control functionality. We don't have anything yet because we haven't initialized our software to be a Git repository. So we can't see anything just yet, but there is something, there will be something to see on this tab after we set up version control. So VS Code supports a subset of Git commands, and also there are a couple of extensions that you can install that might give you some extra functionalities with regards to Git. There is Git Graph, which can help visualize your repository and different branches, and Git Lens, I think, which provides some further support for Git if you want to use it. We don't ask you to install those extensions, because we won't be needing them for this course, but you can use them, and they tend to be very useful. The next one is the run and debug. So again, we can't see much now because we haven't set up our project yet, and we can't run and debug it yet, but that's a useful functionality that you might want to use when debugging your code. The one that looks like a little matrix is the list of extensions. So you might have seen that already because you've installed the at least the Python extension for Visual Studio Code by Microsoft.com. And here you can see a number of others that I've mentioned, the Git lens, and I think we've mentioned autodoc string as well at the setup session, but we will mention this again tomorrow, I believe. This is one of the useful extensions that you might want to consider installing it, but again, is optional, it's not required for this course. And then finally, I think this is a new one. I think I've never used this one, and this is probably your sessions with your agent if you want to code with an AI agent. I assume that's it. I'll ask Philly and Steve, that they are our AI experts. Is that what you use for coding?
We actually have that icon.
Oh,
in
you
our
don't
VS
have it?
Code. No.
I've not seen this before either. I think it just showed up maybe when I updated the VS Code. But we won't be using this in this course. Okay, so now that we've opened things, I think it's probably time to take maybe a short break. We are all already an hour into the teaching, and people might appreciate a short break. So I'm going to stop sharing and give everyone a chance to just have a little bit of a break and stretch their legs and get a drink. So we shall be back at, let's say, 21 minutes past the hour. So 15 minutes break, and I'll put a message in the chat. See you all soon. Hi, everyone. Welcome back. Just to make sure people are back from the break, can you give me a green tick using Zoom reactions when you rejoined? So green tick when you're back. Let's have a look. Okay. Thanks very much for that. So let's have a quick look at our software project. We are going to inspect what it is that we received and try if we can try and see if we can understand and make sense of what's going on in this project. So the first thing that we might notice is a folder called Astronaut Data Analysis Old, which presumably is previous version of the analysis, or maybe acting as some sort of a backup. As we will learn, there are better ways to keep previous versions of the software. So for us, this folder will be redundant, but I know we've all done this before, where we made copies of our work on our local machines and called them backup 1, backup 2, or version 1, version 2, version 1.a modified, version 1.a modified with comments or something. So yes, this is one of the things that we don't really need to keep track of once we start using version control and track our changes that way. What else do we have in our software project? So we have a file called data.json. So presumably this is the NASA data on spacewalks that is used in this project. This is a JSON file, so this is one of the standard data exchange formats or data serialization formats, and we can have a quick look at what this file contains. So looks like it's got the fields called EVA, probably for the ID of the spacewalk, the country of the crew, members of the crew as well is the next field. So you can have you have a list of people who are who were part of the crew. You have the vehicle field to record what kind of spacecraft was used, the date of the spacewalk, the duration in hours and minutes recorded as a string, and then the purpose of the walk, and I believe that's the last field. So this is what our data looks like. What else we've got? We've got a Python script that's not very long, and we will spend some time trying to familiarize with what it does, but just looking at it at a glance, it looks like it is reading the data from our data JSON file. It's trying to open a CSV file for writing, so it looks like it's probably converting the data from JSON to CSV and trying to record that. And if you look at further down the code, it also performs some calculations that we will hopefully understand, and then it makes a plot to visualize the results and the calculations or the analysis that it did. And as I said, we will give you a couple of minutes to try and understand this code. We are just exploring the project for the time being. So what else? We also seem to have this hidden file .ds underscore store. So can you give me a green tick if you can see this file, or a red cross if you can't see this file in the project, just to see how many of you can actually see it. Okay, so I can see that Andrea can't see it. What about others? Okay. So quite a few people can't see it. Oh no, no one can see it. Okay. So this is because I think VS Code by default is configured not to show some of these hidden files. So what you can do is if you go to your settings, so for Windows users, it would probably be code preferences settings, and for Mac users and Linux users, it might be settings. And if you search for the string files exclude, you might see that there is a pattern to exclude this .ds_store files, and you can remove that pattern. And if you remove that pattern, oh, sorry, I mistyped the exclude. If you remove that pattern, you should be able to see the hidden files. So if you do that, and if you manage to see the hidden file ds_store, give me a green tick. So go to your settings in VS Code. So it might be preferences settings, or it can be settings from the top level menu. And then search for the string files exclude. And see what patterns are currently excluded, so they're not being displayed in your file explorer. And give me a green tick if you've managed to remove the pattern, which I have removed, so that's why I can see this file. Okay, so I can see some green ticks showing up. Another way to see the hidden files is if you open a terminal. So I've got a terminal opened at the bottom of my screen, but if you go to terminal in the top level menu and do a new terminal, you can just type a command ls-la to list the details of all the files in your current directory, and then you should be able to see this file. So whichever way you do it, you should be able to see this hidden file. And when opening a terminal, if you are a Windows user, make sure that you open Git bash terminal. So you can see the type of your terminal here at the right corner. And if you click on this drop down and do a new terminal, you should have a Git bash terminal somewhere. So make sure you open a Git bash terminal rather than a command cmd terminal or some other terminal on Windows. So yeah, give me a green tick if you manage to see this hidden file. So the thing with this hidden file is, so the .ds_store file is a file that macOS creates in every folder, and it stores some user-specific settings like icon positions and window size and so on, background colors. And that's something similar to Windows desktop.ini file. So this makes us think that the person who originally created this software used a Mac machine. But this file shouldn't actually make part of the software project. While it's relevant for the machine where it was developed on, we don't really need to share this file as part of the software project, because other people might not be using Macs, and they might be using different operating systems. So there is a way to ignore these files from our version control, which we will see how to do later on, while these files can still remain on people's machines where relevant. Okay, so looks like people in general managed to find this hidden file and see this hidden file, but it just highlights the need to be able to exclude these files from our version control because they are not relevant for the software project itself. Okay, so let's now spend a couple of minutes looking at the code itself and trying and see if we can understand what the code does and how it's organized. So while looking at the code and trying to understand what it does, I'd also like you to write down in this next exercise anything that you think is not quite right with this code, that's not clear, maybe it's missing or could be done in a better way. So I still have one red tick. Gunnar, just checking with you that you managed to get the hidden files to show up, or is that an old
Yeah,
green?
well, I've deleted it in the shell. I mean, I can't edit that setting in VS Code. It doesn't allow me to.
Okay, but you can see it from the terminal.
I've deleted it, so yeah, we don't
Yes,
need that
yes,
file. Yeah.
yeah. Well, don't delete it because we are going to ignore it using Git. But yeah, I mean, you might
Too late.
delete it. That's okay. Right, so I'm going to, unless one of my colleagues has pasted the link to the exercise in our shared, let me just see, in our shared document, I'm going to paste the exercise text here. So once again, what we are doing is we are assessing the software project. So inspect the code and data and try and see if you can understand what the code is doing and how it's organized. And then in the shared document, write down anything you think is just not quite right, not clear, missing, done wrongly, could be done better. And then we'll go through that list and see how many of these things you've identified, and then we are going to improve some of these things over the course of the workshop. So let's spend about 5 minutes or so looking at the code. I'll stop sharing to give you a chance to get your screen back. How are people doing? Do we need a little bit more time? Did anyone actually manage to understand what the code does? I know, first time I looked at this code, uh, it was like a cipher to me. But I have to admit, I don't code with Python that often. But it shouldn't be that hard to understand the code. There are better ways to write the code that makes it more readable. Um, yeah, let's have a look at what things you've identified, and I'll just share my screen once again. And have a look at oh, people are still typing. Let's give people a few more minutes. So if we look at the code, I think you pointed out quite a few of things that are wrong with it. Well, first of all, you noticed that the file paths are hard coded and that they are absolute rather than relative. So unless you have exact same exact same file path on your machine, there is no way this code is going to run for you. So we are going to look into improving that over the course of the workshop, and also we will go one step further and make sure that we can pass the data to analyze, and the result file where we want the converted data to be saved to be passed as command line parameters. So you don't actually have to deal with these paths at all. I think a couple of people pointed out that some of the variable names are well, meaningless. You don't really know what they mean. Things like W, or I think someone asked what J is. J is I think the loop variable defined here. So variable names like T, W, TT, not very readable, not very easy to understand. What else people have identified? I mean, if we look at the file names, the data.json is also not a very descriptive file name. My code version 2 is probably not a good name for the Python script either. It also contains blanks in the file name, which can cause problems when running code on command line. So this is not a good practice at all. Also, if you notice, the version control is embedded in the file name, so you have version 2 in the file name. This is also something that we won't really need to do once we start using Git to track and version control our software project. I don't know if anyone noticed, but it was mentioned before, field names is a variable that's never used, so it just clutters the code, and can probably be removed. If we look in the field names for our data file, you may notice that there's some spaces as well. That's also not good practice. Column names or field names shouldn't really have spaces. I think someone identified that we are looping through the data, and we are hard coding the number of rows that we are reading from the data. This is not a good practice at all. And it's also not very reproducible, because what happens if you get another data file which doesn't have 375 rows? Your code will essentially break. So this is definitely not a good practice. Also, if you've noticed, we are reading the data from the JSON file quite manually. We are reading it line by line and then parsing and deciphering what's inside, what variables are inside. There are standard libraries in Python that deal with reading data. For example, Pandas library, reading data from a JSON or a CSV file and reading it into a data frame, which enables you to work with data in a more standard way. So we shouldn't really be implementing these kind of functions and re-implementing the functionality that already exists somewhere else and is provided by another well-known and well-tested library. So that's also something that we would advise against, because it would be more error-prone reading things like that manually yourself. What else was identified as wrong? So directories are hard coded. Yeah, so we've got these kind of things. Do we need the loops? Can we find a more efficient way? Well, that's a good point. As I've mentioned, there are standard libraries that deal with reading data like this into well-defined objects like data frames. Script names are not descriptive or useful exactly. So no, there are no functions. Yeah, the code is one big monolithic piece of code. There is no modularity to it, no little pieces of functionality extracted in functions. There are no doc strings, no comments. If you have a look, there are some comments. There are some comments in the code, I believe, but the comments are actually used to change the flow of the code. So if you don't want your data to be saved as a spreadsheet, then comment this piece of code below, and then this line as well, commented if you don't want your data to be written to a spreadsheet file. So this is definitely not a good practice to use comments to comment out and bits and pieces of code to change how the code flows. So there are definitely better ways to do that, as we will learn. How about installation instructions and how to run the code? There is no documentation. So it's not just that there are no comments, there is no documentation about this code. Also, can we actually reuse this code? So there is no license file and there is no README file to describe the project and state under which conditions we can reuse this code. So presumably, if you got this from a colleague, you're free to reuse it. But in general, if you come across a piece of code that looks like this and doesn't have a license attached to it, you're legally not okay to download and use this code. And this is an important thing to note as well. So a couple of other things that are really not that well implemented here. And we will cover them as we go along. So what we are going to try and do now is we're going to try and run the code. Well, I think we've already identified that this code is most likely not going to run on our machines, but let's try and do that nevertheless. So I'm going to head to my terminal and I'm going to type a command to run this code. So for me, it would be Python 3 because I'm on a Mac, but for you, it might be Python if you're on Windows. If you're on Mac, Python command may run as well, but for me, I need to type Python 3. So I'm going to type Python 3, and then because the script contains spaces, I need to escape spaces by typing a backslash and to escape the case characters. So for me, to run this code would look like this. And I'm getting an error, a file not found error, which is what I would expect. So please give me a green tick if you manage to run the code in a Git bash or a Z shell or a bash terminal on your VS Code. And if you get a file not found error, and give me a red cross if you didn't manage to get this error. So the error is Python is telling us that it can't find the data file on this particular path, which came from someone else's machine. So green ticks or red crosses, please. If you don't want to type these backslashes, good practice is to include your file name in quotes. So it will be my code version 2.py if you're typing the file name on a command line, and it should give you the same error. So green ticks. Looks like people managed to do that. So as you've seen, we can't even run this code on our machine, so it's not very reproducible. We would need to change the paths for our machine, and everyone who wants to reuse this code would have to change this path, and that's not a good practice. So we can do better than this, as we will see. Okay, so what questions or issues people have at this point? Is anyone struggling to follow? Okay, so what we're going to do now is, let me just bring my slides. We are now going to have a better start with our software project. So we are going to move from having this script and some data bundle into defining a proper software project that we can carry on working and that other people can join and collaborate on, and that we can track the changes to and what we do to this project. So we will try and create well, a proper software project out of this script. So what are we going to be looking into this episode? So we are going to start and do some first batch of fixes for either improving quality or reproducibility of the code. So we will fix the file naming, we will fix the absolute paths. We are going to start using the version control locally. So we will create a software project and put it under version control locally on our machines. We are also going to create a repository on GitHub for backup that we will sync up our local repository with, and we will also set it up for sharing and collaboration with others. And we will start tracking identified problems and issues and the work that we want to do on this software project with GitHub issues. Okay, so before we do that, let's have a look a little bit about Git. Would people like a little Git refresher, or are you okay with version control? Would you like me to just do a quick recap about the basic Git flow workflow that we use when working with Git, and maybe do a little recap of what version control is and why we use it? So maybe give me a green tick if you'd like a little refresher, or if you're okay with Git, give me a red cross and we can skip that. Oops, apologies. Just have a look at reactions. Okay, Oh, there are a couple of green ticks. Okay, so I understand that some people know this already, but I'm just going to spend a couple of minutes for the benefit of others who might appreciate having a little refresher. So what is a version control system? So these version control systems are tools that let us keep track of changes in files over time, and allows us to travel back in time to check what happened in the past, and we can compare earlier versions of the files with the current versions and the current state. So you can think of version control system like track changes in Microsoft Word document or maybe in a Google document, but version control works on any files within your folder, and it's also a lot more powerful and a lot more flexible. So version control, Git is one popular version control system that we are going to be using as well, and typically version control systems have developed to track changes in software projects, but they do not have to be applied just to software projects and to code. They can track changes in any file, basically, and they are particularly effective with textual files. So things like your source code files in Python or C, in R, and so on, but also data files like CSV, YAML, JSON, and so on. They will also track changes in binary files like images, but they wouldn't be necessarily able to show the differences nicely between binary files. So you can still track them. You just won't be able to visualize the changes. So what we have here in this diagram shows the basically what Git does. So Git stores files in repositories, which are basically directories where changes to the files are tracked. So the different parts of the Git system are on your local machine. You have your working directory, the staging directory, and your local repository. So when you start working with Git locally, these are the three parts of the Git that you interact with. So your working directory is your local directory where your project files live and where you are actually doing your work. And this is also called an untracked version of Git. So any changes to files will be marked by Git in this working directory. And then when you save changes or tell Git explicitly to save the changes, by using git add command, Git will stage those changes for committing later on. So the staging directory, also called index, once you tell Git is the place where once you tell Git to start changes to your files with git add, it will then prepare or stage any changes to a number of files in this staging area. And the staging area lets you bundle a couple of or group a couple of changes together to several files, which will then can commit or do a snapshot of by doing git commit command, at which point everything that you've staged, every change that you've staged will then be recorded in your local Git repository. So your local Git repository is saved in a special folder, hidden folder called .git within your working directory. So this is where Git keeps all the changes to your software project. And then you have another part of the picture, which is a remote repository. So that's a copy of your local repository somewhere else on the internet. Normally we use GitHub because GitHub provides a free place for us to store our repositories. And you interact between your local repository and remote repository by using git push command to push your local changes from your local machine onto your remote repository or copy of your repository remotely. and then you use git fetch to bring up any changes from your remote repository that perhaps your collaborators have done back onto your local repository, so you can bring back changes that other people have done. So that's the basic flow. Finally, you can use git checkout command to bring those changes that you fetched from local repository back into your working directory, so you can have all of those changes to work on. And then there is a git pull command, which is a shortcut for git fetch, which is followed by git checkout. So what questions people have about this basic git workflow? Okay, so looks like we might be able to move on. So I'm going to bring back my VS Code, and I will clear my terminal. So the first thing that we want to do is, I think we can safely remove this. We are going to start tracking changes to our code, and we don't really want this old version of the code there because we will be using Git now to track any changes. So what I'm going to do is I'm going to remove this old folder. I'm going to type rm-r to remove a directory, so -r for recursive, to go inside this directory and delete that before I turn this software project into a Git repository. So I'm going to execute this command, and you might notice that it's gone from my file explorer. You can also do that from the file explorer by right-clicking on this directory and deleting it. Okay, so I'll just give people a few more seconds to remove this, and we are now going to proceed to tell Git to make this spacewalks a repository. So we do that by issuing the git init command. So git init tells Git to initiate this directory as a Git repository. Okay, so you should have gotten this message from Git telling us that it initialized an empty Git repository, and it tells us the path where it is. As you might recall, Git stores a repository in this special hidden folder called .git, so you might be able to have a quick look at what's inside. Normally, we only let Git deal with files in this folder. We don't really modify or touch these files, so we can just let it be. Okay, so let's have a quick look with the git status command to see what Git thinks about our repository. So Git tells us that we are on the main branch, we had no commits, and then we have a couple of untracked files. Okay, so what we want to do is we want to tell Git to start keeping track of our data and our code. So we are going to do that by issuing the git add command, which will stage these changes before we commit them to our local repository. So if I type git add and then my backslash space code backslash space version2.py, I'm staging this file. So you should follow along. And then I'm going to do the same thing with the data.json file. So git add data.json. And then I'm going to issue a git status command just to check what Git thinks about our project now. So by giving these git add commands, we told Git to start tracking changes basically to these two files. Git hasn't committed these changes yet, so it just knows that it should track them. It has staged them, but it hasn't actually done a snapshot or a record of these files. So what we need to do is we need to do a git commit command to tell Git to take a snapshot of these changes we've just done. So I'm going to say git commit, and then we need to give Git a message with -m. So this is the commit message that will get recorded alongside this commit. So this commit will add the initial space walks code and data. Okay. And you should type something similar. I'm going to press enter and let Git do. Let Git do its thing. When you're giving commit messages, you should try and make them as informative as possible. These are short messages, so you don't really have, I think, around 50 characters. You don't really have a lot of space to type, but you should nevertheless try and make it meaningful, because if you ever look back in the past, you would like to know what each commit did. So basically, when you type this message, you should write the sentence as if you're completing a sentence saying this commit will, and then what's your commit message. So this commit will add the initial spacewalks code and data. There is a way to add a longer message. So if you put a line break before you finish with the quote, if you put a line break, Git will allow you to type a multi-line extended commit message. So you can do that as well. Let me just clear my terminal. And then if I add a status message now, oops, apologies, should be git status. Git status. Now you should get a message like this. We are on branch main. There are no uncommitted files, but Git has detected that we still have one untracked file. So what happened now is all the changes are now recorded somewhere in this .git folder. Okay, so the first thing that we want to do is probably we want to rename this Python script so that it doesn't contain spaces. So I'm going to use git move command to tell Git to rename MVs for move. So git move my /code /space v2.py. I'm going to rename this file, and I'm going to use underscores. So rename my file, Python file which contains spaces, to use underscores. If I issue git status command now, you can see that Git has staged this change. So it detected the rename. So I'm going to proceed to commit this now. So I'm going to say git commit this change -m, and my commit message is, so this commit will remove spaces from Python script file name. And I'm going to commit this. So if you can give me a green tick once you've managed to rename the Python script file name to remove the spaces and replace them with underscores, give me a green tick. If you haven't gotten there just yet, give me a red cross, please. Okay, so looks like people are getting along. So I've got a little challenge for you now. I will paste the text of the exercise for you in the shared document. Okay, so what I want you to do now is you've got below line 177. We are going to actually use some more meaningful names for our files. So rename our Python script to be called, let me just put some backticks there. So make sure that our Python analysis script is called eva_data_analysis.py, and our data.json file is called eva-data.json. Okay, and then also rename the plot file as well to be called cumulative_eva_graph.png, and then stage and commit these changes in your Git repository. Okay, so let's spend 5 minutes renaming the file names and also updating the file names and paths within the Python script. And also then staging and committing these changes in your Git repositories. Yeah, Andrea, you got a hand.
Yes, sorry, can I ask a couple of questions?
Yes,
So,
go ahead.
first, my .ds file, ds store something, doesn't appear like untracked. I don't know why. I'm seeing that yours has like untracked. I
So
don't
what
know
does
why
your
it's
appear
not.
as?
There's nothing next to it.
So when you do Git status,
Maybe I have committed it somehow, I guess.
that's okay.
If that's, yeah, I don't know
We
if that's a
will
problem.
soon we will tell Git to ignore it, and then you should be able to delete it. And
Okay.
if it appears again, if you're on a Mac, then it will just be ignored. It will still be there. I mean, we don't want to necessarily, your operating
All right.
system might be creating some of these files, and you might need them on your machine, but you just don't want to share them with everyone else because they will be irrelevant for other people working on this software project. So that's why
Okay.
Git has this ignore functionality where you can still have some files hidden or not in your on your machine, but just not share them with everyone else.
Okay.
So that's
And
absolutely
also
fine.
when we delete a file,
Hmm.
we don't do like git add this file because it doesn't exist anymore, right? So do we
If
just
you do,
commit
if you
to,
do, if you remove it just on your operating system, then Git might detect that something's changed. So you can do, I think git rm command should do it, or git move or something. So maybe and that should be enough. So Git, you should be able to remove things with Git. But if not, then sometimes you need to re-add, even if it's a deleted file, you need to do git add, and then Git will detect that it's removed. So it's a bit maybe not intuitive. So not quite sure what
okay.
situation is with your current local
Oh,
repository.
I before the workshop, I thought we had to already sort of have it in Git. So I had it with the folder that we just removed. And I don't know how to keep track of this change now, because it does, like, I don't think I have to do git add something because this something is removed.
Okay, yeah, I know what went wrong. It's okay. We'll help you at the break, and we'll get your Git repository sorted. So what I want you to do in the exercise is rename these two files, and then also within the code rename the files. Put the paths to your files with the renamed file names, and then do the same for the plot file as well. So you've got some suggested names. So we want to call the data file EVA-data. This should be called EVA underscore data underscore analysis, and then the graph file should be called, for example, cumulative underscore EVA underscore graph.png. So that's the exercise that I want you to do now. So I'll bring back the text of the exercise for you, or you've got it below line 177. Okay, and give me a green tick when you finish that. Jen, you've got a hand. Can't hear you. I can't hear you. I can see you're unmuted. Just can't hear you, but I can see you typing. The question from Jen in the chat is that we use both hyphens and underscores, and yeah, that's potentially another not so good practice. Maybe you can just be consistent and use one. We tend to use dashes for data and underscores for Python file names and functions. But regardless of what you use, you shouldn't be using blank spaces. So feel free to be consistent if you want, and just use underscores. Don't forget to give me a green tick once you've done that. Just give people another minute to complete the exercise, or if you need a bit more time, let me know. And then I'll take you through the exercise. I'll do things on my machine as well. Okay, so what the exercise asked us is to fix the file paths and rename the path to our data file. So we were asked to call this file eva-data.json, and I'm going to put a path that is relevant to the current directory instead of the full absolute path. I'm going to do the same with the CSV file where we want to save our data to. So we are going to call this eva-data.csv. And I'm going to call the myplot file cumulative eva graph.png. So I'm going to save that. I'm also going to rename my Python script. We are going to call it eva_data_analysis.py. Actually, I probably should have done that with Git. So you can either do that from the file explorer, or you can do it. I'm just going to clear my Python terminal. You can do it with the git move command to rename the file. So git move, let's do that with the data.json file. So data.json, I'm going to call it eva-data.json. And for anyone who is following along, I will give you just a couple of seconds to type this command. I'm going to press enter. So what we've done is we've fixed the path to the data.json file to be a relative path, and we renamed the file from which it reads the data. We've done the same for the CSV file where we are converting the data to, and also with the plot file where we are saving the result graph. And then we've renamed the file as well. So I'm going to issue a git status command now. So what I have here, and you might have a slightly different situation if you've used git move command on both files, is that git things that we've renamed, apologies, the data.json file. Because I didn't use the git move command, it detects that I've deleted one file, but it detects that there is a new file in the repository. So basically it detects the renaming as two separate commands. So I need to do git add. And I think this might be the question that Andrea had, that even though you renamed or deleted, you appear as if you have to add the file. So you need to re-add it to the Git staging area to tell Git to then be able to commit this. So git add eva data underscore analysis dot py. And if I do a git status command now, now this is what we should be having. So Git detected the changes to these files. So I'm going to do git remove of the my underscore code underscore version 2 file, and then issue git status again. And now we actually have the situation where we want to be. So Git now detects that we renamed 2 files. It was a little bit of a roundabout way because I renamed 1 file through the VS Code graphical interface rather than using Git commands. But we got there in the end. So I'm going to commit these changes now. So git commit -m. What this commit is going to do is going to be, well, implement more informative file names. Informative file names. So this is the situation where we want to be now. And if anyone is not in the same situation, please give us a shout, and we'll get you there. I'll have a look at I've seen green ticks showing, so that's really good. Thanks very much. So what we want to do now is we want to rerun our code. Actually, we probably should have rerun our code before we committed this last commit. But let's have some faith that maybe our code is going to run. I'm going to clear my terminal so that it's a bit more visible for you. So I'm going to type Python 3 or Python, might be Python on your systems, and then EVA underscore data underscore analysis.py, and see what happens and if I get any more errors. Okay, so I got another error telling me that I don't have a module called matplotlib installed on my machine. So some of you might not get this error in the case you've got matplotlib installed, but this is a mistake that commonly happens, and it's easily rectified. So we need to install matplotlib. But we will look into this in just a second. What I want to do now is that we have Git set up locally. I want to make sure that we've got a remote counterpart of our local repository so that we can sync the two up. And so let's go and do that first before we fix the matplotlib dependency issue. So if we have a look at if we head to GitHub and log in, I'm already logged in, so I can have a look into my my profile or my repositories, for example. So give me a green tick if you've logged into GitHub. I'll give you a few seconds to do so. Okay, can see some green ticks. So in order to create a new repository, we will just click on this green button here, new, and then we get presented with the create a new repository dialog, and then we are going to create a space walks repository. And then we can type a description. For example, we want to say something like EVA data and analysis code. We are going to choose the visibility as public so that everyone can see. That doesn't mean that everyone can write to this repository. We are going not to add README, and we are not going to add .gitignore, and we are not going to add the license for the time being. Normally, when you start from a repository afresh in GitHub, it's a good practice to do add a README file that you can then later modify. It's good probably to add a .gitignore file as well, and a license. You can choose what license you want to be added. However, because we are starting from a local repository that already exists, if we add these files now, our local and remote repository will get out of sync, and then we will have some problems to solve. We don't want to do that. We just want a blank repository on GitHub that then we will copy our local repository to. But again, when you don't have this situation, if you're just creating a blank repository from GitHub, it's a good practice to actually add these files, and then Git will create them for you. So I'm going to push the create repository button. And then Git will helpfully gives us some commands to either create a new repository on the command line from this repository. That's not what we are doing. We already have a local repository on our machines. What we want to do is we want to push to an existing repository from the command line. So this is our scenario. So what we want to do is we want to basically execute these 3 commands in our software project. So I'm going to copy the first command and then go back to my terminal to execute them. The important thing is before we do that is if you've got HTTPS option turned on here, important thing is to flip this to SSH. So that's why we've set up the SSH keys. So we are going to be using SSH to authenticate when we push to this remote repository. Okay, and then copy the first line. It will contain the locator for your repository, and then go back to the terminal. I'm just going to clear my terminal so it's a bit more visible. So I'm going to now add a remote, let's say URL to the remote repository that I want to sync up, which is the repository I created under my GitHub account. Okay, so I'm going to press enter to that. The next command we want to run is we want to tell Git that the main branch will be called main. We've already done this as part of the setup, but it doesn't hurt to run this command again and then go back and run the last command, which actually tells Git to push whatever we have in our local repository to send that to our remote counterpart. And the -u command is actually telling Git that the current local repository should track the upstream. That's -u for repository, which we identify with the name origin. Okay, so if I run this command, and if you run this command, you should get a message similar to this. Next time when we run the git push command, we don't need to do the -u flag. You only need to do that for the first time to make sure that the 2 are linked up and track that the local one tracks the remote one. Okay, so I'm going to clear the reactions, and then I'm going to ask you all to tell me when you've done these 3 commands. Okay, I can see some green ticks coming, and I think it's probably time for a break now. We've been Well, I've been talking for an hour. I think people might appreciate the break. Andrea, if you want to stay behind a few seconds to have a look at your issue.
I think it got sorted with what you said earlier with the
Okay.
remove. Like I did that and it worked well.
Okay,
Thank you.
fantastic. Okay, so glad that that worked. If people have any questions or comments, feel free to stay. Otherwise, we shall be back at
I have
15
a
minutes
question.
break. So 48 minutes, back at 48 minutes.
Alex, I do have a question. Can you hear me?
Yes.
I don't think it worked for me. I didn't get the enumerating objects 9. And I think I missed that this on your...
Yeah. Do you want to share your screen instead of me? Let's see where you are.
Yeah, sure. Sharing is not allowed.
Okay, should be allowed now.
Alright. This is the one. Yep, this is the one. I think I missed something. Sorry, I'm sharing. Can you see my screen?
Yes.
I think I missed that something.
So if you type, what does git status give you?
Nothing.
So maybe you can restart your terminal. Maybe kill this terminal. So it looks like it's hanging,
Yeah,
or
it's
maybe
hanging.
there is something blocking it.
Yeah.
So there, you know that there is a little cross button towards the right. Yeah, that one.
That
So
one.
that one, and then if you go terminal, if you go go to terminal in the top menu, terminal, and then new terminal.
Yep.
And then so if you type git status there, let's see what you've got. So you've got all the files are committed. If you maybe also go to your file explorer, so all the way to the top left, and then click on that file explorer icon. No, that one. Okay.
Yeah.
So so if we look into, so you renamed the EVA.json, EVA-data, and then inside the data analysis,
Yep.
what have you got? Did you rename all yes, you did.
Yeah.
And then, so have you got your remote repository set up?
Yep.
Okay, so when you do that first command, git remote add, so when you copy that command, and when you go into your terminal, so it's already been set.
Yep.
And then when you do git push -u origin main, what does that give you?
Oh, it's hanging for some reason. Did I miss some? I think I missed a folder now, the git.
No, what I think is happening is if you type
I may need a new terminal.
if you type let me just give you the command. I think something's
missing.
you know, from let me just have a look. Maybe the authentication, something has gone wrong with let me just, we did kind of, I think, tried that command. So what does, if you run this command, I'll put it in the chat.
Shall I kill this one? Shall I kill this one?
No. Well, you might need to, because is there anything popping up on your?
Nothing.
So kill that one and open a new one. Terminal, new terminal. And then kill all the other terminals, you know, that the two git, the one, yeah, delete them, yeah, trash them, yeah, that's right, those, yeah. Okay, so if you type this command,
In your chat, no?
yes, I wonder if something's it's trying to authenticate and something's happening on your machine.
Sorry, I can't see your chat. Because of the view. How do you change
It's SSH minus capital T
SSH capital
minus
T?
capital no minus T. It's like minus and then capital T.
Yeah.
Capital T, and then space, git at github.com.
Git
At the symbol, like an email address, at github.com.
GitHub.
Github.com. No, GitHub. No, not hub.com. Github.com. Git at
Git at
github.com.
Okay, sorry. Is that one?
What does that give you?
Is this correct?
Yeah.
SSH dash T git. Oh, okay. But give does not provide shell access. Shall I try again that one?
So when you say when you type git remote minus v, just to list all your remotes. Remote, git remote.
One word or
remote, not remove, remote.
So
minus v. Yeah, like that. Like, what do you get?
okay.
So something's wrong with. So when you do git status or git log, yeah, you got some commits. So just press Q to exit that Q. So git push. How about git push origin main? Let's see what that gives you without the minus u.
Git push origin main. Is that correct?
Yeah.
Oh no.
Is it hanging again? Is there any window that pops up?
Here it goes. It says the extension wants to access a GitHub account.
So you installed the Git extension. So can you log in there? Okay, kill this command first. Kill this terminal first again. Okay? Kill that, open a new terminal. Or authenticate.
New terminal.
So looks like you've set up a Git extension.
I see. So this
So
is the
type git. Yeah, can you log in? Can you log in to your GitHub account?
Okay.
The one that you just logged in on the GitHub website.
Log in. Okay. This is the
No,
one.
so you're already logged in, but you need to log in that extension. Or disable the extension. So go back to VS Code.
VS Code.
Type git, so to pop up that window again, git push minus u origin main, and then see what pops up. Okay, so now it's done. Did you you close that window that blocked you, or you authenticated or something?
I think so.
Okay, so you're all done. So you can go and look on your GitHub and it should be
Is this the one?
yeah. So if you refresh that, you should see your code.
Yay! Thank you so
Okay.
much.
No problem.
Does it matter?
Okay.
Because I have another question. I'm sorry.
Yeah, go ahead.
I see you have a folder here with the .git. I don't have that one. Does it matter in your VS Code?
It's probably being hidden. It's not being shown. So if you go back and do that settings and what was that? Exclude or something. File exclude. Maybe type file : exclude. Yeah. So you see, it's your patterns. It's your patterns exclude the .git folder. But if you go back to the terminal,
terminal. Yep, I'm here.
And then type ls minus LA, ls space minus LA. That's to list all of your files and folders, including the hidden one. You can see the .git folder.
Okay. So it doesn't matter if I show it or not, as long as I, okay.
So VS Code is showing, is hiding you some of those hidden files. So like we've told it not to hide the .ds underscore store folder file, because I wanted to show you that there are some hidden files
Yeah, yeah.
that can be ignored by Git, but perhaps should be there in your software project. And it's the same with the .git. So the VS Code is trying to be clever and hide those hidden folders from the view, but nevertheless, those files and folders are still there. So
Okay.
it's up to you whether you want to see all of them or not. I think I prefer to see everything just to have a clearer situation of what actually is going on. On the other hand,
Yeah.
if you see these files and if you start messing with some of them, maybe if you start going into the .git folder and start doing some changes, you're likely going to break your local repository.
Yeah. Okay. Might be better to just show that
Yep.
one. Exclude. I think it's this one that was excluded, so I'll just delete this one. Yep, it's showing now. There you go.
Yep. Okay.
Thank you so much.
Oh, you're very welcome. You've got 5 minutes break left if you don't
Oh,
have any
sorry.
more questions.
I'm good. I'll take a break. Thank you.
Okay, I'll see you in 5.
See ya. Bye.
Hi everyone, welcome back from the break. Right, so just before the break, we've created a remote repository for backing up and syncing our local work with. And we pushed all the changes we've done locally to our repository and synced up with our repository on GitHub. So if we look into our GitHub repository now, and if we refresh, we should actually see the files and all the commits that we've made to our repository so far. So let's just spend a few minutes looking at the GitHub repository and maybe orienting ourselves and highlighting some of the functionalities of GitHub and highlighting the ones that are most commonly used or might be immediately useful to yourselves. So you can see these top tabs, different tabs that Git provides for us. The first one is the code, which gives you to the takes you to the landing page of your project. We can see the files we've committed. You can see the commits there. You can see all the past commits as well. We've had 3 commits so far, or at least I had 3 commits so far. If you've not been following exactly what I've been doing, you might have a different number of commits. We can actually click and have a look into what we've done so far back in the history. Going back to the code repository, it shows you the source code or folders, subfolders, all the files that you contain in your repository that are being tracked. And this is where the main development work is done. Another tab, which is also very important, is the issues tab, which is used by GitHub to let you add issues to track bugs or tasks or feature requests or any other work that needs to be done around your software. So this is the tab that you will likely use very often, and it's a very useful to have because you keep all the work or issues or planned work or tasks or activities around your software project together with your code, and it's really useful to have everything located in one place. The next tab is the pull requests tab. So this tab is where basically any contributions appear by other team members or collaborators on your project. So if they want to submit some changes to your code, they can then be viewed and discussed here on the pull requests tab before they get merged into your code. So if you work with collaborators, you will often use this tab. Another one that I want to highlight is the actions. Skipping the agents tab, which is something new, but this is not something that I've used before. It's probably again one of those AI agents and functionalities within GitHub. The Actions tab is for automated workflows. So things like automated tests, automated deployments that run on your project using GitHub Actions, continuous integration and deployment functionality. So we will touch a little bit upon this when we do tests using continuous integration, but this is a relatively advanced side of software development. You've got the projects tab. This enables you some project management facilities. So you've got different views over your either your tasks or things that you have to do table view, board view, roadmap view, and so on. That also integrates with your issues and also integrates with pull requests. So it's a very useful project management facility to have a look at what needs doing by who and when. And also these projects work across different repositories that you might have access to. So you don't have to have a project just for a single repository. If you have multiple repositories contributing to a larger project, you can project manage them from these project boards. There is a wiki tab as well. This is where you can create some structured documentation for your project. Typically, software projects have their own documentation. For example, as we will see, you can generate documentation with some other tools. But if you don't use that documentation built in as part of your software project, you can use the wiki that's afforded to you by GitHub. Whichever documentation tool you use, it doesn't really matter as long as you provide some kind of documentation around your software. There is security and quality tab as well, provides some analytics on the project activity. This tab, it helps you identify and manage some vulnerabilities in your code and dependencies. Sometimes some dependency or code that you are using might not be secure or has some security loopholes, and then GitHub has this facility where it scans the code that lives in GitHub and notifies you of some known vulnerabilities, either in your code or in some of the libraries that your code depends on. You can have insights as well. Insights provide some analytics about the project activity, contributions, the health of the community around your software that you might want to look into. And then finally, you have settings. This is where you as a repository owner can set up and configure how your repository behaves, how others interact with it, who has what kind of access, and so on. So this is just at a glance overview. I think the most commonly used ones and the ones that will be useful to you immediately are the Issues tab, the Pull Requests tab, and the Actions tab as well. And we will look into some of these things a little bit during the course of this workshop. So I'd like you to now start working with the issues immediately. Well, when we assessed the software project, we identified quite a lot of issues with it and things that could be improved. So I'd like you to start tracking some of these issues here. We will create one issue just to get an idea of what these issues look like and what you can actually do with it. But you can think of issues as a record of the work that needs to be done or a problem that needs to be solved. But GitHub also affords you to describe this issue in more depth. You can attach screenshots or code snippets or some other images. You can reference other work and other commits and pull requests that happened before this. You can mention team members to draw their attention to this particular issue or to ask them to comment. And then you can carry a whole conversation around the issue. And again, this is very useful because on slightly bigger projects, where you have a bigger number of contributors, it's important to keep these conversations going, and then everyone who has access to the repository will know what actually happened and what decisions were made and what actions were taken. And if you keep those kind of conversations together with your software repository, then this knowledge doesn't get lost. You might use some other documents to record the decisions, but keeping everything together is very useful, and you can always go back to it and find things relatively easily. Okay, so what we will do now is we will create one issue. We've, I think, identified that there is quite a few variables in our project that don't use very informative names. So if we go back and have a look at the code, so variables like W or T or TT or TTT, I think we've got quite a few that that look meaningless at a first glance. So what I want you to do is follow me with creating a new issue that will describe this problem with our code. So I'll go back and click on the new issue button to start this dialog to describe the issue at hand. So let's say we want to improve variable names. So this is the title of our issue, and I'm going to give a little bit more description here. So I'm going to type rename variables was WTTT to be more descriptive. Okay. And I'm going to create this issue. So I'll let you finish that, and then we'll just have a quick look what else is available to us with these issues. So first thing is I can assign issues. So I can assign responsibility for a member of the team to look into this issue. I'm currently the only member of this team, but we will see later on. We will add our collaborators, and then we can assign issues to people. So this is important. So there is some responsibility for the tasks. So I can click assign myself, and you can do the same if you want to. Another thing that you can do is you can label your issues. So this is a standard practice where you group issues. So for example, commonly used labels are, I don't know, status in progress. So someone wants to indicate to the rest of the team that they're working on this issue. Status can be blocked as well. So you can have, oh, this issue is blocked by something else that needs to happen beforehand. You can also prioritize issues and assign labels. Say high priority, medium priority, or low priority, things like that. So these are fairly arbitrary labels that you can assign, but there are some conventions around some of those kind of commonly used labels. And then if you click on the labels, Git also has a suggested standard set of labels that you can use, but you can also add your own labels if you want to and define for your project. You can also assign an issue to a project, so you can project manage it as well from the project board. You can also assign it to a milestone, which normally is used when you're planning some work and you're sprinting on a certain number of issues, for example. So you want to define a milestone and assign a subset of your issues to this particular milestone. I won't go into the details. We will come back to issues later on. We will show you how you can comment on issues, how you can close issues, and so on. If you go back to the issues tab or refresh the issues tab, you can see that now we should have one issue showing there. And this is the practice that we will try and carry on. So every time you detect that something needs doing on your software project, you should create an issue and assign a person to look into that. Okay, so I'm going to pause now because we're going to move on to the next episode. What questions or comments people have? Yes, Jen, you've got a hand.
Hello, can you hear me now?
Yes.
Yes, okay. So I actually just wanted to ask, is there a way to create a new issue from, for example, the terminal, so we don't have to go to GitHub?
No. So Git is different from GitHub. Git is a command line tool. GitHub is a remote service that enables you to link up your Git repository from your machine to a remote location provided to you by GitHub. So all of these facilities that we are looking and functionalities that we are looking in now are provided to us by GitHub. So this is all extras that GitHub puts on top of like a standard Git repository. So you can't You can't close issues or you can't close or open issues from command line is the short answer. You can refer to issues in your commit messages. So you can commit, so each issue, if I click on this, each issue has a number. So this is issue number 1. And if you want to comment on an issue, you can refer to it. So issues, as we'll see, will be, you can reference them by using the hash symbol and the issue number. Does that answer the question, Jen?
Yes, thank you.
So it's a combination of tools we are using here. We are using Git, which is a command line tool, version control system, with GitHub, which is built. It's a service built on top of Git, but provides all of these extra functionalities, communities, around projects. It's a really good question. I think it's good to highlight the difference between Git and GitHub. Okay, what other questions people have? Is there a question in the chat? So someone says there is a GitHub command line CLI tool, command line interface tool. So is that, Garo, is that a tool to help you open an issue from command line? So maybe I was wrong.
No, well, as I say, I've never used it, but it looks like you might be able to do it. Yeah, just from scanning the documents.
I stand corrected. I've never used it myself. So at least not from the standard Git interface, you can't.
Yeah.
Question 1 from Sambit. Is it possible to migrate projects from GitLab, managed to university, to GitHub? Yes, the question is yes. I don't know if there is some automated sort of workflow, but you can definitely check out your GitLab project locally on your local machine. You can then initiate a GitHub repository from your local projects, like we've done with this software project. We had some code and data. We initiated GitHub repository, and then we pushed that repository to GitHub. You might want to maybe clear up some of the GitLab metadata that's stored in your project, because you don't want to store that with your GitHub project. But yeah, it is certainly possible. And the question 2, how much of this setup and workflow changes if we are working a GitHub group managed by external authorities, for example, Met Office? So not quite sure what the question is here. Do you want to maybe elaborate on that question? So you want to move a project from GitLab into what? Met Office GitLab.
Hi.
GitHub, sorry.
Am I audible?
Yeah, go on.
Yeah, so basically I work with a project under a project with Met Office, and they have this GitHub account where we have been granted access based on our university email IDs. And we are basically basically using a fork of some of the repositories that they have and working on them, modifying them. And we are basically hoping to merge some of our modifications back to the organization level GitHub repositories. So either we can host our own separate copies of it, and then probably we can also ask them to, or raise a pull request basically to merge the modifications. So how does that work? I mean, because let's say for example, when I'm committing from my local version of the Git repository from my machine, how would I then commit the changes back if the authentication is managed by Met Office under their group? So will it only be committed to my local or my account version of the repository, the public version or the private version, and then I would have to hop back to the group level? So I'm just confused on this.
So what you would be able to do is, if you had access to Met Office's repository, as in write access, if you're added as a collaborator. So we will cover some of these things later in the course. So if you are added as a collaborator on the Met Office repository, so you have write access, you can make pull requests directly onto that repository from a branch created on that repository. If you don't have access to that repository, but the repository is public, so you can read basically from that repository, you would need to create a fork of that repository in your GitHub account. So you will have like a copy of that repository on GitHub. So both repositories will be on GitHub, but the one that you forked will be owned by you, and you will have write access to it. Now that repository you could check out locally, and then you can work on that repository locally. You can then push changes to your fork on GitHub, and then from there you can do a pull request. So from your fork, you can do a pull request to the Met Office repository, okay? And then that way you will be able to contribute. So you will be doing pull requests in any case, but either from the branches on the repository, of Met Office repository that you have access to, or from a fork of that Met Office repository that you don't have access to, but you want to contribute. I don't know if that makes sense.
Yeah, that makes sense. Yeah. Thank you so much. Yeah.
Okay. Well, we'll talk about this collaboration workflow a little bit more, I think on day 4. So there will be more opportunities to talk about this. What other questions people have? It does take some time getting your head wrapped around all of these different repositories and where they reside and what it means, and how you sync them up. So I think it's important to spend some time clarifying. Okay, so if there are no more questions or comments, let's move on to further improving our software project. So what we have now is we have a software project we have a Git repository attached to it, and then we can track the changes that we do, and we can sync up those changes with our remote backup on GitHub, and we've also can potentially enable others to see and contribute to our project. So we now need to move on and actually start improving all of those things that we've identified that are not so good with this project. But all of this setup ahead of the coding that we do was necessary to enable us then to be able to track all of these changes and things that we are doing. So if we have a look at our code, and you might remember last time we tried to run our code, we got this. Let me just run this again. We got this module not found error, so we are missing some dependencies, or at least I am missing on my machine some dependencies that are needed for this code to run. And if you look at the code itself, you might notice these import statements peppered around the code. I think we've identified that it's not really a good practice to have them placed randomly around the code. The convention is to have these input statements placed at the top, so you can immediately see what dependencies your code has. Imagine if this code was hundreds and hundreds of lines. You don't really want to be scrolling down to see what dependencies you need to install. So that's the convention, the reason for the convention to store the dependencies or input statements at the top. So anyway, we basically need to install these required libraries in order for the code to run. So we've got the JSON library, the CSV library, the date-time library, and the matplotlib library. So some of these libraries, like JSON and CSV and datetime, are now standard Python libraries. So you can just import them. You don't really need to install them. However, matplotlib is not a standard Python library, so you would need to install it. Normally, to install these packages, we use special tools that are called package managers, and we will be using pip package manager for Python. There are other package managers to use if you're using Conda. Conda comes with its own package manager and environment manager. So you may use Conda. There are other tools for Python. There is a whole different ecosystem of these different tools. So we will be using pip for this course, and we will be using venv to create a virtual environment to encapsulate our software project. So we will be using these two tools. Later on, you might decide to use some other tools for this. I think someone mentioned UV at the start of the workshop. So that's another tool to manage your environment and your dependencies. Whichever tool you use is up to you. Perhaps it depends on what your team or group is using. It's important to use something. It doesn't matter which one you use. And again, other programming languages have similar mechanisms to manage dependencies and the virtual software environments. They might not work in the same way as for Python, but they really exist. So whatever programming language you use, it's an important practice to make sure that you manage your environment properly. So hopefully the knowledge that you pick up here might be transferable to other programming languages. So the thing with these virtual environments is they are self-contained environments that we create per project, which enables us to encapsulate a particular version of Python installation with a number of separate and external libraries. So the reason why we want to use that is that if we have multiple Python projects on our system, we want to be able to specify what versions of which libraries each one of them use, and also which version of Python each one of them uses. It's quite possible to have multiple versions of Python running on the same system. Actually, I should probably show my my slide, because I might actually be able to describe things better. So why do we need to isolate our project environments? So you only specify what you need for a specific project, so that includes Python version and your software's dependencies. And as I said, you could have multiple versions of the same library installed, but required by different projects, and also multiple versions of Python. Sometimes you might have a legacy Python 2 project, so you might want to be able to run Python 2 and Python 3 alongside on your machine for different projects. So that's why we create this project-specific environments. Another thing with these project environments is that once you define them, they can be described and shared. So they are described in a special file, metadata file, which you can share with your project, so that others know by looking at that file what your environment looks like, and they can easily then relatively easily reproduce that environment on their machines, which might be on a different operating system, a different platform. And also the same goes for you. If you're working on multiple machines, perhaps you have a desktop in your office and you have a laptop at home, you might want to be able to replicate these environments on your multiple machines. So there's loads of benefits for isolating your code, and this is probably one of the first things that you should do when you start working on a software project. So here is a nice diagram that actually hopefully depicts this situation with virtual environments that you create per project. Some programming languages actually, I think, handle these environments by not effectively installing the code every time in each of the projects. You actually have libraries installed only once on your machine, and then they tend to point to these versions of the libraries that you're using. And unfortunately, I don't think that's the case with Python. I think the Python actually, when you create a virtual environment, it actually puts the code of the dependencies inside that, so it does replicate and copy copies the version of the libraries on your system multiple times. But there you go. Okay, so, oops. So what we are going to do now is we are going to start creating a virtual and setting up a virtual environment for our project. So let me just clear my terminal. In order to create a virtual environment, what we do is we type the Python command. It's Python 3 for me, -m, and then venv. So this is to fire up the venv tool or Python module. So that's why we have the -m. And then, so we are telling the venv tool to create a virtual environment in the root of our software project. So I'm going to call venv underscore spacewalks. I'm going to call our virtual environment venv. Oh, sorry, didn't type that. venv. Ah, I made a mistake. So I mistyped my environment. Oh, that's okay. I'm just going to delete that folder and then type that again. So Python 3 -m venv, and then the name of the environment we are creating. And I want to call our environment venv underscore spacewalks. Okay, and you might have noticed that we've got this folder created for us for this virtual environment. So I'm just going to give you a few seconds to create this environment. And maybe one of my co-instructors can paste the command for you in the chat if you want to copy and paste that. If we have a look at what's inside this virtual environment folder, if we look in the bin folder, you might see the links to Python versions that we want to use, Python version that we want to use for this project. It might look slightly different on your machine depending on what Python you've got installed. You also have a couple of configuration files. Normally, we don't modify these files in this folder directly. If you are on Windows machine, you won't have the bin folder. It will be called scripts for you. So it will look slightly different. And then you might have the include folder as well. This is where the virtual environment will store, again, some files that we don't want to look at. There is the lib folder as well. This is where some of our dependencies are going to live. I think it's in the site packages is where the packages that we require for this project will live. So a little bit about the naming convention. I have deliberately called our virtual environment venv underscore spacewalks. Conventionally, these environments are called either venv or .venv to make sure that this folder is hidden. However, if you have multiple projects on your system and then you have all of those virtual environments called venv, then you might not know which one you're at. So again, when you do this for your software projects, you can name your virtual environment whatever you want. You can call it venv as well, or .venv as is convention. But just to make it easier to follow this course, we've decided to kind of break on this convention. So you've created this environment now, but we need to activate it. It's still not active. So in order to do that, we type the command source venv underscore spacewalks bin for myself and people on Macs and Linux, or scripts for people who are on Windows, and then activate. So we need to run the activate script basically to activate this environment. So maybe if my co-instructors can paste the command for Windows in the chat, that would be much appreciated. So it will be source vn_spacewalk/scripts with capital S/activate for Windows users. And then you might notice that my prompt has changed. So now this indicates that I'm in the inside this virtual environment called vn_spacewalks. What have we done actually? If we check now which Python we are using, so type which Python 3 or which Python for Windows users. Let's have a look what we get. So you may notice that by creating a virtual environment, I got a copy of Python within my, or link to a Python version within my Spacewalks software project. So that means that for this specific software project, I will always use the Python which is within the virtual environment. So I could potentially have different Pythons on my machine, and the one used for this project will be linked from the bin folder within my virtual environment. So that way you can isolate projects which use different Python versions. Okay, so can you give me please a green tick if you manage to create a virtual environment and to activate it? Okay, so that's good. What we want to do now is we actually want to tell VS Code as well which Python interpreter we want to use for this project. It's a good practice to do that because VS Code will remember which Python interpreter we want to use, and then we'll use that one in the future for us. So even after we close VS Code and then reopen it again. So in order to do that, what we want is we want to get the copy of Python. So navigate to the bin folder within your virtual environment and go to Python 3 and do a copy path. Okay. Or maybe Python for you, Python 3 copy path. And then if you click Control Shift and P on Windows or Command Shift and P, that will bring the command palette in VS Code. So Command Shift and P on Windows and Mac OS, and Control Shift and P on Linux and Windows. Okay, and then if you see this option Python select interpreter, you can select it. If you don't see it, you can start typing Python : select interpreter, and then it will show up. Select that option, and then select the enter interpreter path option, and then paste that path and save that. Okay, so let's try that again. Bring the command palette, select interpreter, and then enter interpreter path option. Okay, so this will save this for your project inside VS Code. This is VS Code specific setting, but it will make your life easier if you carry on using VS Code. So if you've done that, and if you select your Python script now, you should be able to see your virtual environment showing up here at the bottom as well. So for me, I'm using Python 3.14.2, and my environment is called vn_spacewalks. So you should be able to see that. So now that you've done that, you can also run your Python script by using the run button from VS Code. Okay, if you prefer to do so. We tend to type the Python command and execute the scripts on the terminal, but you can do that. And VS Code now knows which Python to use for your project. Okay, so is everyone okay with this? Any questions?
What did we have to look for, like to change the interpreter in the
It
top
was
bar?
Control or Command Shift P, the command palette, and then there is a setting which is called Python Select Interpreter.
Actually, I wondered, why don't we use the set project environment instead?
You could use that as well. You could use that as well. I think by doing this, actually, that gets saved in your project environment. This is an extra step that you could do if you're using VS Code. But VS Code also will detect that you've got a virtual environment in your software project. So that should work as well. That should be enough. But just to be sure, you can select and specify the Python version that you want to use for this particular project. And that will save you some reconfiguring in the future. Okay, so now I think we've got the, let me just see if I can clear the reactions. Then we can move on. Now we are ready to start installing our dependencies for our software. So in order to do that, we type Python 3 -m pip install, and then the one that we need to install is matplotlib. Okay? So we are now using the pip tool, which we are invoking as a Python module. So that's the -m pip. Install matplotlib. You might have seen commands like pip install without the Python 3 -m, but in doing it this way, you make sure that you invoke pip, which is attached to the Python version that you have in your virtual environment. So you will always be running the correct pip, as it were, in the case you have other pips installed on your system. And pip now comes with as of Python 3.3, it comes together with Python distribution if you're using the standard distribution. So this way, invoking it as a Python module ensures that you're running the right thing. So I'm going to install matplotlib, and I'll just let it work. Okay, so matplotlib has been installed. If I want to see what matplotlib I've got installed, I'm going to use the Python 3 for me. Python 3 -m pip show matplotlib, and I'll get some information about the package that is installed for me. Okay. On my machine and the version, you can scroll up and see all the details. I'm going to clear that. And then if I want to see what other packages are installed in my current virtual environment, I will issue a command Python 3 -m pip list. Okay, so this is the stuff that I've got installed, and matplotlib is the one that I installed, and it's got some dependencies, some like NumPy, so it installed some other libraries for me. So this is basically what my virtual environment looks like. So what I can do with this environment is, we said we want to be able to share this environment with other people who want to run our code, or maybe ourselves on a different machine. So there is a way to capture this environment. So we do that with Python 3 -m pip. So it's a pip freeze command. So if I type Python 3 -m pip freeze, and then the output of this command will come up on my screen or on my standard output. So I can run this command, and then you get the environment. But what I do want to do is I want to capture this in a special file. So if I run this command again, Python 3 -m pip freeze, and if I redirect the output of this command into a file, and by convention we call this file requirements.txt, which is stored in the root of the software project. So requirements.txt, by convention, when you see this file in a Python project, you will know that it contains the recording of the environment. So if I look in my project explorer now, file explorer, you can notice that now I've got this new file created for me, which captures the versions, the libraries and the versions that are installed in this particular virtual environment for my software project. Okay, so give me a green tick if you've managed to do a pip freeze and to save your requirement in requirements.txt file. Okay, so it looks like people are following along. So what we want to do is we want to be able to share this file with our collaborators. So this is an important part of our project. So let me just clear my terminal. So what I can do is do a git status now to see what git things has changed in my project. So git sees the new output file that was created for me when I last ran the project, and also sees I can track this file, but I don't want to. It's a results file that I can recreate. What I do want to track is I want to track this requirements file because I want to share it. So what I'm going to do is I'm going to do git add requirements.txt. Okay, so I want to stage this file and tell Git to keep track changes of it. Okay, and then I'm going to commit git commit -m initial commit of I want to commit that. So this file, requirements.txt, it absolutely makes sense to share. What doesn't make sense to share is this virtual environments _ space box folder, because that folder should be created on each individual machine by people who are collaborating. Okay, so Git enables us to ignore files that we don't want to share. Okay, so and Git does that by saving these files to be ignored in a special file called git ignore. So what we can do is we can create that file now, either from the Project Explorer, or I'm just going to create an empty file by running a touch command. So touch.gitignore. Okay, so I'm going to do the gitignore command. And you can see that I've got an empty file here now. So what I want to ignore now, I want to ignore this vn folder. So vn underscore space walks. So you just basically put on a single line either the path or a file pattern that you want to ignore and save this. So I want to ignore the space vn underscore spacewalks folder because that's a virtual environment created on my machine. Everyone else who is collaborating can recreate the virtual software environment from this file, and I'll show you how in a second. So now if I do a git status command, you may notice that we've got this new git ignore file. Now that file I do want to commit to git, so I want to say git add.git ignore. Okay. So then other collaborators can know what is ignored as well, and they can add their own things to be ignored if they want to. Okay, so I'm going to do git commit -m. What are we going to do? This commit will ignore the vn folder. Okay. So a quick exercise for you all. What other file do we want to ignore? We had this .ts_store file. So let's do a quick exercise to ignore that file. So what would you do? Can someone tell me? How would you ignore this? What would you need to do? Anyone? So we would need to add another line to the .gitignore file.
.ts.
Dot on a new line .ds_store. Okay, yes, exactly. We can also do one better if we git ignore understands patterns, and so if we say /.ds store, it will ignore not only the .ds_store file in the current directory, but in any other subdirectory of this project. So we can completely ignore all of these files. They will still remain on Macs that need them, but they won't be shared with other collaborators. I'm going to save this, and then I'm going to do a git status. So now Git is telling me that I've again modified the .gitignore. So I'm just going to do git add.gitignore and then git commit -m. So this commit will ignore the Mac OS .ds_store files. Okay, so if I do git status now, there is nothing to commit. I've got one untracked file, but that's okay. And I'm also ahead of my remote repository by 3 commits. So what shall I do now to sync them up? What command do I need to run to push these changes remotely?
Git push.
Git push. And then origin, which is the label for my remote repository. And I want to push on which branch? Main. Is that right? Okay. So my main branch gets pushed to the main branch on the remote repository, which is labeled origin by convention. Okay, So let's do that. Right. So our software project is looking in a slightly better shape. Let's try and run our code again. Actually, give me a green tick when you've pushed. Okay, that's great. Let's try to run our code again. So running the code again. And this time I'm getting some graph generated for me, and the data saved in the CSV format, the input data. Okay, so at this point, we got some results. We don't know whether this graph is correct or not. We know that the code managed to run, at least on my machine. And we got some results. Okay, so we've kind of battled through the first set of issues in order to run and understand the code we inherited. Quick question. Has anyone gotten an encoding issue? Or did everyone manage to run the code? Did anyone get a data encoding issue like this? We always get at least one participant on this course that has this issue, but sometimes it can go undetected and it's quite subtle. Okay, so looks like everyone's machines managed to run the code.
It looks like there's a few people in the chat who
Okay.
who've got that
Oh, I
problem.
didn't see the chat. Right. Okay, so that's good. That's important. Yes. Yes. Okay. So it's really good that at least some of people got this, because this is another thing that we want to highlight. Let me just go back to the code. If we look at our Python code and look how the data is being read and written. So it's done with this command. We are opening the file for writing, and then we are opening another file for reading. So the problem that some of us had is the problem with character encoding. The problem is that we don't know what the character encoding was used when the original data was saved, and also we are not specifying the character encoding when we are saving our files. So this is a really important practice. We should always be specifying the encoding in which to read the data in and in which to write the data out. Obviously, we don't know what the encoding was when someone saved this file, but we can make a good guess. So with the encoding, the standard Latin characters are typically encoded using the ASCII encoding, but the expanded Unicode character set covers many more of these characters. So if you have look at the error message, some people got. Let me just show it again. Oops. So it can't read some characters, which are then represented with \x 92. So obviously in this data file that we have some non-standard Latin characters for which the ASCII encoding won't work because it just doesn't map that sort of character set. You need a Unicode or some other encoding to map a larger set of characters. So when we read the file, Python converted those characters into Unicode characters. Now, by default, operating systems have they use different encoding under the hood. So for example, Windows will try to write these characters as UTF-7 encoding, which is a different encoding. and saves a little bit of space compared to another encoding, UTF-8, which is again another standard, but it doesn't include all of the characters. So that's why the Unicode character 0092 got shorted to \x92. But that character doesn't exist in the UTF space. So I suspect that people who had problems were on Windows, and it looked like that Macs and Linux has managed somehow to battle through this issue. So in any case, the way to sort it is we are going to try and tell Python to use a specific encoding when it's reading the files, okay? And we do that by specifying encoding and passing the value. We are going to say ASCII encoding. So when you're reading the file, try and use the ASCII encoding. That's our best bet. It's 1 byte is used to encode every character, and if it doesn't recognize the character, it will just leave the character as is. However, when we are writing the file, we want to use encoding. We want to actually use the UTF-8 encoding. So to make sure that we can encode a larger number of character sets. So as you can see, different operating systems have different defaults, and we shouldn't be making any assumptions, especially when we are working with collaborators who might have different platforms and operating systems. So it's always best to specify this encoding and don't allow any space for ambiguation. So if we save this and try and rerun the code, I wonder if this will solve the problem for people who experienced it. So how are we doing? Did that sort the problem for those people who experienced it?
Yes, yes, it did.
Fabulous. Okay, so this is a really, really important point and could have just went unnoticed if we didn't have colleagues whose machines complained about this. Right, so let's then commit this last change. Stage and commit and push this last change. I'm going to let you do that on your own and give me a green tick. I'm going to clear all the reactions and then give me a green tick once you've done that. I just wanted to show you where these characters are appearing. Line 375, some of these special characters, Unicode characters. And somewhere else, line 362. Okay, so I'm going to do this now as well. So if you issue git status command, you can see that we now have a graph file as well. You could save those results files to version control if you wanted to, but you don't have to because you can always recreate them. So what I'm going to do is I'm going to do git add eva underscore data analysis.py, and then git commit -m. So this commit will specify data encoding, specify for data reading and writing. And then I'm going to do git push origin main to push my changes to my remote Git repository. Okay, so that brings us to the end of today. I'm just going to have a look at the chart. Okay, so everything's looking good on the chart. What we've done so far is well, we've managed to identify lots of issues that affect the quality of software and reproducibility of its results. And we've started slowly to improve our code. We fixed things like file names and paths and some variable names we haven't fixed just yet. That's what we're going to be to do tomorrow. We've started to use version control for our project. We've also created a repository on GitHub for backup and for sharing and collaboration and to sync up our local repository as well. We've also started tracking issues with our work using GitHub issues. We've created a virtual software development environment to isolate our project from any other Python project we might have on our machine. So we've spent loads of time preparing and creating the scaffolding around our software project that will enable us then to do some more things and updates in the future. So it took some time to get started, but we will now make much faster progress now that we have all of this setup done.